Hi, everyone. As I can see some participants are still joining, but we have the majority of you. So I want to welcome you all and thank you for joining us today. My name is Noah Glumshare. I'm the Director of Marketing at Hunters. And we're very excited to have you with us for this first webinar of the year for Hunters. We have more to come, so stay tuned. We have a very special guest webinar today, Mr. Sounil Yu, who is CISO in residence for Wild Ventures. And he's also served in the past as CISO for Bank of America. Sounil has been kind enough to join us today and share his vast knowledge in knowledge and the use of it in threat detection and response. And joining him is Hunter's CEO and co-founder, Uri May. They'll be presenting both of them. And looking at our agenda today, we're about to walk you through a technology which is also applied by Google, LinkedIn, AstraZeneca, and many others. As you're about to see, knowledge is a critical theme in threat detection and response, and trust you'll learn how a knowledge graph, which is a particular use of it, enables better and explainable threat findings. And more importantly, how Hunters XDR uses that. I do want to say as a final note that throughout the session, you can submit your questions through the Q&A chat box. We'll dedicate 15 minutes at the end of our session for a live Q&A session with our experts. So stay tuned for that and let us know at any point what your question is. Without further ado, Sounil, please take the lead. Thank you.
Thanks, Noah. And thanks for the opportunity to share some perspectives on threat hunting and knowledge graphs. I wanted to make one small correction to my introduction. So yes, I'm a CISO in residence over at Wild Ventures. I was the chief security scientist at Bank of America, not the CISO. I wouldn't want to claim that title. It would keep me awake.
Thank you.
So anyway, well, in the past, I used to run a hunt team. And when I ran a hunt team, we used to really struggle with having enough data and information to be able to understand what's going on in our IT environments. Today, I think we have quite a lot of data at our disposal. Sure, I mean, we can always get more, but we oftentimes don't utilize the data we already have. And this is oftentimes because I think the data is siloed and disconnected. And we want to enrich this data with threat intelligence from various sources. But oftentimes, we're not really getting intelligence. We're just getting a lot of recycled artifacts that have very little lasting value on their own. And our hunters have to figure out how to make sense of all this while drowning in all this data and information. And many organizations just don't have the right people even, or enough people with the right skills to be able to make sense of all this data. So it's clear to me that just having data and information is not enough. What we need is to be able to move up this stack that is called the Dikw Pyramid. So DIKW stands for data, information, knowledge, and wisdom. And as I mentioned previously, I think we have plenty of data, which are discrete facts, signals, and observations. And I think we have plenty of information as well. This is data that's been processed or organized or structured for some purpose. It may even have been enriched so that it's endowed with meaning and purpose. But what we really lack is the capture of knowledge and wisdom. How did you discover that hash? How did you discover that C2 domain? How did you know to look at that running process? What we're talking about is this mix of experience and contextual information, environmental factors, expert insight, and grounded intuition that provides a framework for evaluating and incorporating new events and information. And to go further up the pyramid to wisdom, what we would want to understand is why should we take some action on something given the whole picture, which would include the business context and the impact. But being able to capture knowledge and wisdom requires a more methodical and holistic approach to how we hunt. So one of the frameworks that I have used to think through this problem and to make it a little easier to grasp is something that I created called the Cyber Defense Matrix. It's a simple 5x5 matrix that incorporates the 5 functions within this cybersecurity framework on one dimension, and then 5 asset classes that can get compromised. So devices, applications, networks, data, and users. I use this matrix to organize and understand what data I have. The structure of the matrix also helps me to understand or know if I might be missing something important. Am I missing any important data elements? And if I am, where might I find it? Now, many existing detection and response tools leverage this data to look for intrusions. And we'll find various tools in the market that consume this data and information. And these manifest in asset-specific capabilities for detection and response, such as endpoint detection and response, network detection and response, and UBA. I don't quite know what the right category names. I don't think there are market names for the application and the data space yet, but you get the idea that there's this notion of using asset-specific data points to be able to do detection and response. But intrusions and the artifacts that they leave behind don't happen in isolation. And we're chasing an adversary that's constantly trying to elude detection. So to move more efficiently from the known to the unknown, we want to be able to take advantage of all these data sources to understand what is going on in our environment. That's where I think the notion of XDR comes in. I see the X sort of like a wildcard, indicating that we want to leverage all this data to be able to detect and respond to intrusions. But again, just having this data doesn't mean that we know how to put it to use. This is where I think the matrix is also helpful. It can give us a perspective of where we can start and where we should go next when it comes to the hunt. And in particular, I think it can help us understand how to connect these data elements into a set of causal relationships, which essentially is that knowledge graph that we've been talking about. To understand how to do that, first, I need to define 4 categories of awareness. Let's suppose something unusual happens on the network and we see some alert about a potential intrusion. We want to get situational awareness of what's going on. To get situational awareness, the first step should be to look for what I call structural awareness of the asset, where we saw the alert. So for a network-centric asset, this can include things like domain names, IP addresses, communication paths, and so on. But this might not be enough to get full situational awareness. To complete the picture, we want to connect our structural awareness with insights from other assets in our environment. I call these insights environmental and contextual awareness. Dividing up the data into these 4 categories allows us to understand how they connect, how they may connect from one to another, and provides hints to the hunt team on where to go next in case they run into a dead end. So let's see how this works with something on the endpoint and show how these different types of alerts come into play. Stepping through the sequence of discovery, let's suppose we have some alert on an endpoint suggesting that it's behaving oddly in some sort of way. The first step is to gain structural awareness of that endpoint. We might find that the endpoint is fully patched and locked down. In other words, we basically run into a dead end. There's basically nothing structurally here to indicate why this endpoint might be acting oddly. This means that we need to gain wider environmental or contextual awareness. And so from here, the analyst needs to choose where to go next. What we may discover is that the user of that endpoint has a vulnerability. Specifically, the user has failed their most recent phishing simulation test. Furthermore, the user hasn't completed their phishing training and awareness program, so the user remains vulnerable. And this would prompt us to seek out contextual awareness to see if that user may have recently clicked on a phishing email. And if they did, this insight would lead us to increase our situational awareness sufficiently to understand what events might have led up to that endpoint becoming compromised. This example shows how the cyber defense matrix helps us to understand where we might need visibility, what to look for or to perceive in that visibility, and how to connect the dots to comprehend what we perceive. By capturing these relationships in a knowledge graph, we can provide more intuitive answers to the threat hunter. And there are 2 ways that I think we can take this knowledge graph approach and make it available to the hunt team. First is that we want a simplified interface that enables the threat hunter to query across all that data that we talked about before. And I think Google provides a great example of how this can be done. A clean, streamlined interface with results that are oftentimes remarkably accurate. The only problem with Google's interface is that you don't quite know why the answers you got are ordered in the way that they are. Now, behind Google search engine is a knowledge graph that connects various attributes about who you are, what your interests are, what you might have searched for in the past. And all these things are connected together so that it can return the most relevant results. And really, depending upon your interest and your background and search history and whatever it knows about you, you might get a different ordering of results when you search for something like APT. So Google does a great job of returning these mostly accurate and relevant results because of its knowledge graph approach. However, if the answer or the ordering is incorrect, you might not know why. And that's because Google doesn't actually show you that knowledge graph. And I think this is where something like LinkedIn serves as a better example, or a really good example. When you do a search for someone or something on LinkedIn, it returns a perspective of that knowledge graph with indicators of how the results are more relevant. You know, like how closely they might be connected to somebody, or do you share common interests? When it comes to threat hunting, we need both the simple interface that lets us search across all our data, but also an ability to explain and understand why we got the results that we did. If I search for APT and it showed me a bunch of apartments, well, hopefully it knows, or at least the answer is tied back to the fact that I've been looking for apartments. If I get a different answer, like here's Cozy Bear, then I would like to know why the answer is incorrect, or why it thought that answer was correct. And I think this requirement for explainability is pretty important in security, because when it comes to security decisions, particularly when it might be business impacting, we need to be able to explain how we arrived at that decision. A knowledge graph that shows a clear chain of causality across the 4 types of awareness provides a solid foundation for explaining a security decision. And now there are many security solutions out there that tout ML capabilities, but oftentimes the results that they produce are essentially unexplainable and unrepeatable. Grounding your threat hunting activities using a knowledge graph approach allows you to have that explainability, the repeatability, and overall improves the effectiveness of our threat hunting activities. And so I think the approach that Hunters is taking to be able to produce a knowledge graph approach for, or to leverage a knowledge graph approach for threat hunting is really a great way to go, because it provides both the flexibility to query across a wide knowledge base of information, but also to be able to understand how the answers that I got, really how we arrived at the answers that we got. And with that, let me turn it over to Uri to share his perspectives as well.
Just a second, apologies for that. So yeah, let me start from the beginning. I took the most common pitfall in a webinar and was muted exactly at the time that I needed to talk. And so thank you so much, Sounil, for that amazing exposition. And thank you everyone who joined us on this webinar. I want to take a lot of the concept that Sounil walked us through and tie it back to the implementation at Hunters. And when we founded Hunters, I think that the problem statement and the challenges were very much aligned with what Sounil took us through. Challenging around training and domain expertise, vast amount of data being untapped, high number of siloed data that is only being increasing as the attack surface is growing, with more and more parts of it being monitored by different security products. And we took a very deep quest into understanding what would be the right architecture and what would be the right technology. And the truth is that knowledge representation and knowledge graphs and expert systems, for that matter, is as old as it gets with computer science and AI, for that matter. But it's proved to work really well in environments where you have an analyst or you have an expert and you're looking to empower it. And one of the things that we also understood as we grew and evolved the architecture and the technology is that layer of knowledge representation, the deeper that it gets, the more powerful the ML and the algorithms on top of it gets. And just want to add to all the advantages that Sounil ended with. I think we're seeing a big driver for knowledge graphs also around accuracy and efficacy. So our ability to generate automatic results for detections and also correlations that results in better incident response and more accurate incident response are tightly coupled to the way we represent the data and the way we're building the relationships between them. And before we dive into the specific implementation and the way we chose to represent nodes and entities and relationships on the graph, I just want to add that in compared to a lot of other detection and response products from previous generations, I think that XDR in general, and obviously Hunters being an OpenXDR, is trying to tackle the analytical layer very aggressively. I mean, Sounil talked about it, and I think that the situation now in compared to 5 years ago is very different. I mean, we have huge amounts of data. And data and information isn't a challenge anymore, and also the data layer and the data platforms aren't a challenge anymore. The biggest challenge is around type of analytics, domain expertise, data science that we throw on those huge amounts of data to generate insights and impactful results. So let's dive into the details. This is your attack surface. No, I'm kidding. But imagine your environment as this fabric that spans across your attack surface, across its parts. It could have data points from the endpoint and the network, the identity layer, email, OT, IoT, SaaS, cloud infrastructures, cloud workload protection in your production environment. All of those telemetries, and as Sounil talked about, the environmental awareness and the situational awareness, all of those data and information is being represented somewhere. It's being fed into something that represents your attack surface. And what Hunters does is, other than taking all of the entities and building this fabric that represent the attack surface that we just mentioned, we're also placing detections on top of it. And detections could be native alerts from all of the products that we integrate into. They could be triggers that are the results of our proprietary analytics, looking for specific techniques, tactics, and procedures that attackers are using across the different telemetries that we're collecting. It could be custom detectors that customers developed based on their knowledge of their environment. And it could be triggers that are the result of threat intel feeds, meeting the raw data, and generating indication of compromise from known malicious infrastructures. All of those detections are associated with all of the relationships to entities, and that's what creates basically a fabric of threat signals that are correlated together using automatic investigation capability into what we're gonna see as the final result of our knowledge representation layer. Once we have those organizational contexts and entities and threat signals loaded into our knowledge graph, we can now basically allow analysts, either manually or through automation that we're going to talk about in a second, traverse this graph. And like I mentioned earlier, imagine the cumbersome challenge that an analyst might have today when switching between data sources and switching between parts of the attack surface to uncover a threat or to do incident response for a specific threat. This entire thing is being overly simplified by representing the data in a very structured way, in a very highly correlated way, and also by introducing what we call automatic investigation, which is basically enriching the data, both from external and internal resources, creates more entities, builds more relationships, and makes this graph something that is more highly correlated. And other than giving that access to the analyst, we, like I said earlier, we also found that ML clustering algorithms running on top of this graph now has the opportunity to automatically correlate and score what we call attack stories. Basically, imagine attack story as a highly correlated incident that comprises leads, entities, organizational context, and all of those data points that we've just mentioned together into something that is being prioritized for an analyst to look at. You can always jump between a signal into its position in the graph, but you can also enjoy the ability to automatically correlate attack stories. We found that the correlation strategies that we're running that are generating these stories, and we're going to see an example for one of those in a second in a live demo, is dual. First of all, it gives us the ability to automatically expand our situational awareness and gives the analyst an unprecedented understanding of what really happened. The second thing, which is really interesting, and it's driving a lot of our more novel findings in customers' environments, is the ability to take multiple low fidelity signals and correlate them together into something that has a high sum product of scores, something that is highly prioritized. And that basically gives the analyst the ability to look at areas in their graph or look at the areas in their attack surface that they would have missed in any other way. So without further ado, I think that now we're in a really good time to jump into the demo itself and just take a look on how a story looks like. So this is a story. What you can see here is basically the visual representation of an area of the graph that was correlated automatically and represent an incident. This specific incident is about a malware running on an endpoint. That endpoint is being monitored in this example by Carbon Black endpoint product. And what the malware does is actually extracting AWS credentials and then exfiltrating them into a malicious infrastructure, a CNC server. The interesting thing is that we can see that Carbon Black actually detected and blocked the malware, but by the time of the blockage, the credentials were able to exfiltrate from the system and get into the hands of the attacker. The interesting thing is that by then looking on the AWS environment, we can understand automatically that those credentials were then being used by the attacker to access the production environment. The interesting thing is that when analysts get these insights, they now understand that the focus shouldn't be on the endpoint. I mean, that's a secondary priority. Top priority is understand what's going on in the production environment, because we have a compromised account or a compromised access key. We can choose to track the activity. We can choose to immediately block it. We can choose to contact like the owner. We can do a bunch of remediations. But the most important thing is that the focus point is at the root cause of the risk associated with this attack story. And beside that, you can see that basically there's a really interesting jump between cloud and endpoint that wouldn't be possible without any strong representation that is also linked between the entities and the suspicious data points. And another thing that ties back into what we went through in the presentation is just that different types of detections that we correlate together. So we can see a native detection from Carbon joining a TTP, joining more of a UBA kind of analysis on the behavior of someone accessing the AWS environment from a host without an agent defending it. And all of those types of detections are combined together to basically automate a lot of the processes that Sounil went through when he described the way a hunter or an analyst would traverse the matrix and would get to a conclusion. Another cool thing is just to understand the back end of things and the technology behind this specific story. And you can see that just it might give you a better sense of why we're calling this a graph. So go to something that is a bit more reduced. Basically, the entire story that we saw just now is represented by these main entities. There's a bunch of other entities associated, but I use the view that shows only the ones that are connecting and basically are key components in this story. The white rectangles are the detections or the suspicious data points, and the blue circles are the entities that are correlating them. And the interesting thing is that there are connections and there are relationships that are basically leveraging multiple entities to establish a semantic relationship between two detections or two suspicious behaviors. And this is something that without this type of representation and without this kind of automation on top of the representation would almost be impossible to capture without a lot of manual work, a very experienced analyst that also know what to look for. So hope that it all makes sense. Obviously, there's a lot of other aspects, including the manual investigation capability of the graph and all of the different engines that are running on top of the graph to generate this representation automatically. And before jumping into the presentation itself and the slides, I'll just say that another interesting trait of graph is that they allow us to grow our insights exponentially. And we're actually seeing the more data that we're loading into the graph and the more insights that we're training the graph to understand, the more interesting stories and incidents that we're able to generate, because graphs' nature are to get more and more connected. Obviously, there's a threshold. A graph that is too connected is also not good, but that's why we're working so carefully on designing the ontology and designing the entities and relationships behind it. So backing up to the presentation again in the slides and also summarizing a little bit the things that we went through. The things that we were able to achieve by leveraging knowledge graph technology for detection response, obviously around that accurate analysis. Accurate analysis in our perspective is driving efficacy, obviously, leveraging more and more data sources to find more and more incidents that might have been missed, but in the same time also expanding the context and increasing the accuracy and shortening the time of the analysis. Explainability, which is something that Sounil talked a lot about, and that was a very leading factor in our choice of graphs and in our implementation of the knowledge graph. And you saw it in the representation. We also took it an extra mile further and created like a user interface semantic layer on top of the graph that is able to take that interconnected circles and squares and make something that is easily consumed by an analyst. And the most important thing, in my opinion at least, and that's the exponential trait of it, and that's where I ended up the demo, is the ability to keep on expanding the context. And this technology is something that gets better as the attack surface grows, gets better as we add more integration, more products into it. And the interesting thing about the integrations that we offer, and you can do a vendor presentation without talking about integration in cybersecurity, but I mean, the interesting thing about our approach, at least for integration, is that each and every one of those tools are tools that we're tightly coupled. Those integrations that we're working a lot around, and that's part of the knowledge. Part of our ability to take the telemetry from those data sources and really understand them to the bits, to be able to represent them both with entities and relationships on the graph, but also by leveraging attackers and adversary understanding and developing TTPs and detections that can run on top of them. That's a big part of our success, and that's a big part of what makes hunters something that is able to deliver the results that we're generating in customers' environments. So thank you for bearing with us, and thank you so much, Sounil, for the exposition. And I would love to take questions for the audience. And Noah, I'll hand it over to you to lead us.
Perfect. Thank you so much, Sounil and Uri. That was, although I'm familiar with the story, it was genuinely insightful. So thank you for sharing your knowledge. We have some, we presented a question a few days ago over social media, and we got some really interesting questions from audiences, from various people. And some of them are throughout the session. So I'd like to start with a question actually for both of you. Omar is saying that knowledge is a dynamic thing, and he's obviously right. He likes to know, he has a big team of threat hunters and incident response teams. I know different SOC teams vary. He has a big team, and he's asking how dynamic and customizable Hunter's XDR is. And I actually think that's a question for both of you, or if you want to start, and then Sounil, use your reference and previous experience to follow up on that. That'd be great.
Absolutely. So I can share that, and Umar, that's a great question. I can share that one of the things that we're thinking about when we're thinking about Hunter's OpenXR is that it's not just open from the sense of like the integrations that we have and how open to the world we are. It's also about open in the sense of we want this thing to be extendable, not just extended in extended detection response, but also something that is extendable. And we're doing a lot of work around that in the infrastructure and the platform side of the house. Obviously, from an R&D, there's always a tension, bringing out of the box content versus investing more and more in platform and infrastructure capability. But in the past couple of months, we've kind of like passed the threshold in terms of like focusing ourselves not only on delivering out of the box content, but also delivering capabilities. So very soon you could develop your own custom detections in new interfaces that makes it simpler. You can load your own annotations and asset tagging on top of entities. And that would also be able, you could also by that be able to indicate sensitivity. We're opening up the scoring mechanism and allowing customers to give their own feedback on the way we should score things. There's APIs and portal access to ignore lists and those type of things. And the idea is that all of those things would be documented and noted. So all of the things that we're doing are not just configurations, they're also associated with the person that did it, notes, why did he do that? And we're trying to make Hunters other than the knowledge automation platform that it is, but also a tribal knowledge kind of central location that can also help a lot of teams such as yourself to retain your knowledge and data. Obviously automate what you can, but also make sure that you're maintaining it in a way that is up to date and shareable. And Sounil would love to hear your inputs on it.
Yeah, you actually hit upon some of the key points with respect to sharing knowledge. So in our industry, we talk a lot about sharing information. But if you consider the Dikw pyramid, we want to go past data and information sharing to knowledge sharing. But up until now, we really haven't had a great way to codify that knowledge, to be able to capture that and to share that across teams, across companies even. If you think about what the attackers are doing, they are taking the data and information that we share and making that data and information useless because it's highly ephemeral. So we need to move up that stack as well. The knowledge of how we discovered that hash, the knowledge of how we discovered that intrusion, we need to codify. And I think the way that's captured is in a knowledge graph. It needs to be captured in a way that we can systematically repeat the process for how we discovered an intrusion, not just the byproducts of that discovery. So anyway, I think for any team that's large, that's going to be the bigger challenge. How do you make sure that this information, the tribal knowledge that Udi just talked about, is captured, systematically captured, and systematically improved upon as well? And I think that's going to be a great place for us to innovate and develop over the next couple of years.
Thank you. Uri, the next question is for you. We have a question coming from John, which is very relevant. How does Hunter's XDR fit in my current stack? What do I need or don't need to have it in place?
Yeah, that's a very tactical question, like a very targeted one. So Hunters, like we said, it's an open XDR. We see it as something that can augment your existing data and information layers, such as your SIEM or other types of data lake. But we also see it as a standalone centerpiece for your SOC that includes data retention, data collection, aggregation, and obviously all the analytical capabilities that we've talked about. We have some customers that chose to place Hunters on top of their SIEM. And we had some customers that chose to basically use Hunters also as their data platform to retain their information and data layers. I think that's one of our strengths. And that ties back to where I started from after the segue from Sounil when I talked about our focus. Our focus is purely on the analytical side of the house, but we understand that without all of the pipeline and without also supporting the retention and the collection and aggregation and ingestion of raw data and information, we would limit our impact on a lot of customers that are having a very widely varied types of stacks. So hope that it makes sense. And in any case, if anyone has more questions about their specific stack, always feel free to either reach out directly to me or to anyone from the team.
Perfect. We have an interesting, somewhat provocative question, and I actually want to pitch it to Sounil, if that's possible, although it's more of a product question, but I think it relates to the concepts that we talked about throughout the session. So Pierre says, this all sounds an awful lot like SIEM. You mentioned correlation, you mentioned different points of data. How is it different? Does it replace it at all?
Sure. Yeah, no, great question. And as a practitioner, I really don't want to call this next gen anything, because in 5 years, what exactly is next gen, right? So I think SIEM has its place in our ecosystem, but the evolution of what we've encountered in the use of SIEM is that we needed to be able to put in more advanced detection logic into how the SIEMs operate. And unfortunately, just to put it simply, it was pretty clunky in how in the type of detection rules that we can put into SIEMs. For the most part, it was very much of a, if this equals that, then alert, or if it counts up to a certain amount, then alert. And I think that's just going to be insufficient for our needs going forward as we encounter more sophisticated intrusions that really do transcend any one particular domain and require more advanced analytic capabilities to be able to discern and look for these intrusions. At its foundation, so here's another way I can look at what a SIEM is versus what we see in XDR. So you saw in my diagram earlier, these horizontal views of data going into an XDR, data going into an NDR, data going into a UBA. So you can look at that as more like a depth side of the equation. SIEM also helps with the breadth side. So you can put any number of logs into a SIEM. A SIEM is essentially gathering a whole bunch of logs, aggregating them, and doing some basic correlations. Think of XDR as having that breadth of coverage across different types of data, but also the depth that we need, that we see in the in the EDR, NDR, UBA type of solutions. And we're needing both. We need something that gives us both the breadth and the depth to cover a wider range of assets, up to and including cloud and what we're seeing in SaaS applications and infrastructure as a service and those spaces as well. So I think that's the difference. That's the main difference that I'm seeing. SIEM is maybe on the broad but shallow. The EDR, NDR, UBA are deep but narrow, and XDR is trying to cover both.
Perfect. Or do you want to add on that?
Yeah, just to add to what Sounil perfectly articulated, just from a focus perspective, SIEM vendors are across the last 15 plus years, we're very much focused on the collection and aggregation of data, to follow up on what Sounil said. And like we've talked about already, the collection and aggregation, we can't refer to it as a solved problem. It's not solved, it's challenging, but that's not where the detection response value would come from. Detection response would come from domain expertise and the ability to scale domain expertise in an automated way. And that's what we went to in this presentation, the automated knowledge representation that we're building in Hunters using knowledge graph technology. And it's definitely confusing because, and we get that a lot from customers, because I think eventually SOCs are going to use one technology as their centralized product for their detection response and SecOps procedures. And we believe that the future, obviously we're biased, but we believe that the future is with OpenXR products that can deliver on the commoditized side of the problem, meaning ingestion, collection, aggregation, and retention, but also innovate very disruptively on the analytical side of the house.
Thank you, Uri. We have around 3 or 4 more minutes until we wrap up, and we did get a big list of questions, but I want to address two additional questions. One is a bit more technical, and the other relates to our discussion about knowledge. So Clara is asking about cloud environments. How do we cover them with Hunter's XDR? She mentions this is one of her most one of her most invisible environments, or kind of where they suffer visibility challenges. So if you can approach that, and then we'll tackle another one.
Yeah, absolutely. So thank you, Clark, for the question. And when we started Hunters, one of the first parts of the attack surface that we invested a lot of research in was AWS in Azure. We were very fortunate to work with early customers that are born to the cloud environments. The biggest one of them is Snowflake. And when we started with them, it was just mind-blowing, like the number of AWS accounts, the number of resources, entities, and suspicious behaviors that happened there. And that really led us to understand that in cloud infrastructures, control planes, the importance of knowledge representation and very tight kind of entity system is super important, because you got your elastic network interfaces and AWS resource numbers and identities and instance IDs, and so much things are going on in cloud environments that without the right representation, it's almost impossible to correlate, and it's almost impossible to generate that situational awareness that we've talked about. So definitely covering the three big vendors, GCP, Azure, and AWS, and doing it, like Sounil mentioned earlier, in a very deep way. And also integrating with other cloud protection vendors and cloud workload protection vendors that are running inside the cloud and are able to deliver native detections that could enrich and expand the context on attacks that are correlated either automatically or manually by analysts traversing the graph. So just to wrap up, cloud is very much one of our biggest strengths and one of the things that we invested the biggest amount of time from day one.
Thank you. And as a concluding question, there's an interesting question here from Roy. We talked throughout the session about explainability and its importance in threat detection and response, and as part of the knowledge graphs. So how visible is this? How is this visible throughout the product? Do users benefit from explainability, and how?
Yeah, so I think that there's a lot of areas. Some of them are softer, but some of them are very explicit. And so, for example, every scoring function that we're developing, and we're gonna also encourage customers to do the same when they adjust their scoring layers, is very highly annotated. That means that every result that a scoring layer is generated is accompanied by the reasoning behind that. And that gives us the ability to stack the results from different scoring layers and explain why the system thought that this specific security event is plus 75 or plus 25. And it's a simple example, but it's something that we took as an approach across the product. And obviously from a higher perspective or from a macro perspective, I think that even being able to explain the way we correlated a specific incident and the entities and the relationships that were involved goes a long way when you compare it to a more unsupervised, without the knowledge graph supporting its capability, supervised learning, where you just end up with a result of millions of features that created a baseline and then an outlier for that, without really understanding what kind of features cause this data point to be an outlier. So I think that, just to wrap it up, there's a lot of concrete evidences, like the scoring layers that I mentioned, but also things that are embedded deeper in the approach and are more visible to the automated results that our system is generating.
Thank you, Uri. If you can skip one more slide, I'd like to use the opportunity to close the session with a poll. So if you can quickly answer 2 questions that would help us understand how beneficial the session was for you. We hope that you enjoyed the session. I want to thank Uri and Sounil again for taking the time and enriching us with their knowledge. If you haven't had the chance of looking at Hunters and what we do in our XDR solution, please go ahead and visit our website at hunters.ai. And we look forward to hearing from you again.